Welcome back, Marauders. This is video 9.1, an introduction to entropy. What entropy means is disorder or randomness. Entropy sounds really similar to enthalpy. So enthalpy we talked about earlier in the year. And enthalpy was represented by delta H for an enthalpy change. And enthalpy was heat. So the words are really similar, entropy and enthalpy, but I don't want you to get them confused. Enthalpy is heat, so it's how much heat is released or absorbed during a reaction, if it's endothermic or exothermic. And then entropy is something else. Entropy is represented by delta S for an entropy change of a reaction. And what that is disorder. So it's how organized the molecules are, the particles are. It's how free they are to move around. And so in this example, during this reaction, it starts out highly ordered, so all the pieces are close together. They're not really free to move around very much. And then after the reaction, all these pieces are independent, so there's more particles, and they're more disordered, they're more free to move around. So that's an example of an increase in entropy. So entropy, delta S, different from enthalpy, delta H. In this section, we mainly want to learn how to predict if the entropy is increasing or decreasing during a reaction, if it's getting more ordered or more disordered. And so as you go from a solid to a liquid to a gas, you always have an increase in entropy, the increase in disorder. If you think about it, a solid, the particles are all neatly arranged, all close together. They don't have much freedom to move around. In a liquid, they have a little bit more freedom to move around, but they're still close together. And then in a gas, they have the most freedom to move around. They're the furthest apart. There's the most kinetic energy. So as you go from a solid to a liquid to a gas, you always have a positive delta S, an increase in entropy. Other ways that entropy can be increasing during a reaction is if a reaction produces more particles of a gas. So if we have a reaction where you start out with 1 mole of a gas, you just have just a few particles moving around and bouncing around. And if during a reaction you create more gas particles, then there's more freedom for them to move around and bounce off the sides of the container and each other. So you have an entropy change that is greater than 0. It's a positive entropy change. You have more disorder when you have more particles, especially of a gas, that are free to move around independently of each other. If you have a gas and you increase the volume of the container that gas is contained in, that'll be an increase in entropy. So here we have gas particles that are kind of condensed in a small amount of space. And if we let them spread out and take up all this space, we have an increase in entropy, an increase in disorder because they're more free to move around. When we increase the temperature of a gas, we increase the kinetic energy of the particles. The particles are moving around faster. When they're moving around faster, they have more entropy. So you can increase the entropy by heating up a gas. So here we see the distribution of the speed of the particles. Here is at a low temperature, 300 Kelvin. And then if we heat it, we shift the whole curve over here to the right. So more of the particles are moving faster. They have more kinetic energy on average. And so here they're moving slow, here they're moving fast. And when they're moving fast, they have more disorder, they're more freedom to move around and bounce off the sides of the container and each other. So heating the gas from a low temperature to a high temperature is a positive delta S. It's an increase in disorder and randomness. And then if we have a solution forming, so if you have a solid and then we dissolve it in a liquid, we make aqueous ions during a reaction. So here's like a solid, they're all close together, not much freedom for them to move around. And if we dissolve that in a liquid and make all these as like independent ions, then they're free to move around, they're more spread out, there's more disorder. And so that would also represent an increase in the entropy or an increase in the disorder. So delta S would be positive for a reaction like that. So the main thing that you need to know in this section is how to predict if entropy is increasing or decreasing. It's increasing entropy, increasing delta S whenever there's more disorder, more randomness. And just a reminder, don't get entropy confused with enthalpy, which we learned about earlier in the year. Enthalpy is delta H, and that's representing the amount of heat released or absorbed during a reaction.